All right, welcome back to Mr. Cooper's class. We are on Module 2, Lesson 11. We're going to hop into the problem set, so let's get to it. So we're bringing in now these things called thought bubbles. We'll get to that in just a second. For now, let's read the directions. Estimate the product, solve using the standard algorithm, use the thought bubbles to show your thinking, draw an area model on a separate sheet if it helps you. So you don't have to draw an area model, but you can use a scratch sheet of paper if it helps you do that. So this is very similar to the lesson, the previous lesson. Let's zoom in real quick and do this estimation part first. So 1 and 38 hundredths times 32, we'd see that 1, underline the number, look next door, 5 or greater, add 1 more. 4 or less, this is 4 or less, let it rest. So 1 and 38 hundredths is going to become 1, right? And then 32, we'd round that to 30. If you're not understanding how I'm doing this, then you need to go practice some rounding stuff, because we're not going to spend all day working on the rounding. We got to be moving forward on the estimating the product. So we got 1 times 30, and that's going to equal 30. Now let's move down here to this problem set. So in problem set 10, we treated this as something like 138 tenths, right? But today we're going to kind of do the same thing, but we're going to think about it in, or we're going to approach it a different way. So instead of having to figure out where my decimal is going to wind up going, I can just treat this like it's a 138 and times it like it's a 138. So let's go through that. 2 times 8 is 16. Keep my 6. Carry my 1. 2 times 3 is 6. Plus 1 is 7. 2 times 1 is 2, right? Scratch that out. Next row, we're in the tens place. I'm going to put a 0. 3 times 8 is 24. Keep the 4. Carry the 2. 3 times 3 is 9. Plus 2 is 11. Keep the 1. Carry the 1. 3 times 1 is 1. Plus 1 is 4. Right? So that's going to give me 4,140 on the bottom, 276. And so when we add down, we're going to get 6. 7 plus 4 is 11. Keep the 1. Carry the 1. 1 plus 2 plus 1 is 4. And 4. 4,416. So what we did right here when we treated this like it was a 138 is we basically moved the decimal, we times the decimal by 100. We moved it out of the way to make it an easier number to work with. But now, as we see here, it says think 4,416 is 100 times too large. What is the real product? As I know it's way too large. Well, I know that my answer is going to be something around 30. That's why we estimated, right? And so my answer down here, 4,416, I know there's no way that that's right, right? If I times by 100, I need to divide by 100 when I'm done. So I've got 4,416, and I got to move the decimal over 2 places to divide. So because I times 100 here, I have to divide 100 when I'm done. So with math, a lot of times we can pull something off or do something at the beginning to make it easier, but we got to remember to go back and fix it when it's done, right? So when we times 100 to make this number easier, once we're done, we got to divide by 100 to give us 44.16. 44 and 16 hundredths is a lot closer to 30, by the way, too. We can tell place value wise that this answer is going to be a lot closer than 4,416. That's like 4,400 farther away versus 14. All right. So basically what we're going to be doing for this problem set is we're going to be timesing by a number, whether that be 100 at the beginning, and then dividing by 100 when we have the product, to make it something. We're timesing it by 100 to make it easier to work with, and then we're dividing by 100. Or I might have to times by something more. I just got to move the decimal over. So let's start right here. I got 3 and 55 hundredths times 89. Well, I'm going to round that 3 and 55 hundredths up to 4. And that 89, I'm going to round it up to 90. 4 times 9 gives me 36, and that 0 gives 360. So I know, because I rounded, this is not an exact answer, but my answer should be something close to 360. So I'm going to think, what would I do to make 3 and 55 hundredths into an easier number to work with? Well, I could do 3 and 55 hundredths times 100, right? And that's going to equal 355. So I'm going to treat this like it's 355. I'm even going to X out that little decimal. And then I'm just going to solve. 9 times 5 is 45. Keep the 5, carry the 4. 9 times 5 is 45, plus 4 is 9. Carry the 4. 9 times 3 is 27, plus 4 is 31. Right? 31. And then I got to do the 8 times 5. So that 8 is in the tens place. I got my 0 right here. 8 times 5 is 40. Keep the 0. Carry the 4. 8 times 5 is 40. Plus 4 is 44. Keep the 4. Carry the 4. 8 times 3 is 24. Plus 4 is 28. So I got the partial products of 3,195 and 28,400. I'm going to add those down. 5, 9, 5, let me carry the 1, 3. 31,595. Now my estimated product was 360. This is 31,000. I know that this is not right. Right, so I'm going to come over here. I'm going to use my little thought bubble. I'm going to say, right there, 31,595 divided by 100. Why divided by? Because I timesed it by 100 to make it easier. Now I got to move it back. And that's going to give me 315.95. Right? Now, when I look at that, that's in the 300s. My estimated product is in the 300s. This is a much, much better answer. Reasonable. I can tell just by looking at my estimation. Right? These both of these numbers, factors got rounded up. So my estimation is going to be just a little bit higher than my actual answer. But 315 is way closer to 360 than 31,595. Right, so that gives me the answer 315 and 95 hundredths. Okay, so let's move on to the next problem. Here it says solve using the standard algorithm. So let's set it up. Solve using the standard algorithm. 5 decimal 0 4 times 8. Now, we've talked a lot about getting the decimals lined up. Right now, when we're doing just one number with a decimal times a whole number, we don't have to worry about the decimals yet. The decimal is basically just going to fall down. So we just treat this like a normal multiplication problem. 8 times 4 is 32. Keep the 2. Keep the 3. 8 times 0 is 0. Plus 3 is 3. 8 times 5 is 40. Right? And then, like I said, my decimal is just going to fall down. That's going to give me 40 and 32 hundredths. I could just guess, especially when I'm dealing with decimals in a whole number, I could just do 5, the whole number of the decimal, 5 times 8, and that's going to give me 40. So I know that my answer is going to be 40 and close to 40, and this is 40 and 32 hundredths. Super close. Okay. Like I said, the decimal, you set it up just the same way you would, and then just let the decimal keep falling straight down with these. I'm going to pause the video and give you a few minutes to try to do these by yourself, and I'll have the answers pop up in 3, 2, 1. Okay, so here we have the answers. I got the final answer highlighted to make it easy. If you got all the answers right, kiss your brain. Excellent. If you got something wrong, go ahead and check your partial products. Just try to figure out what you did wrong. I want to real quickly point something out really interesting right here. Now we see that there's a 0 right here, and then decimal 56. So this number is less than 1. It's a decimal number. It's less than 1. What happened when we timed the number by something that was less than 1? We timed 432. Our product got smaller. Just an interesting thing to pay attention to. When you times a whole number by a number that's less than 1, your answer is actually going to get smaller than the number, right? 0.5 is almost half. It's a little more than half. 241 is a little bit more than half of 432. Just a cool little observation to make. So let's go ahead and move on to 3. Use the whole number product and place value reasoning to place the decimal point in the second product. Explain how you know. So what I see here is if 98 times 768 equals 75,264, then 98 times 7 and 68 hundredths equals what? Now let's notice they both have, I'll color code this real quick, 98, 98. And then the 768 is just like 768 hundredths right over here. Right, they're the same digits. The only thing that's different is the decimal and the place values. So just by looking at this over here, I know my answer is going to have 75264. But where is my decimal going to go? Well, if I had to, right here, if I took 768 and divided it by 100, that would move the decimal from 1, 2, and it would be just like 7 and 68 hundredths. So by dividing it by 100, I could make this be the same. So I'm going to take this number right here, and I'm going to divide it by 100, and that would move my decimal right here, right? Because it would start, here's my decimal, to the left 1, 2 times. Right, so we'd have 752 and 64 hundredths. Well, how do I know that? Well, I could say something to the effect of 7.68 would be like 768 hundredths. Right, so remember what we talked about in the previous lesson. I could read this 768 as 768, and then I just call it whatever, and the unit form would be whatever place value is to the farthest to the right. So this is the hundredths place that this 8 is in, so I'd say 768 hundredths. It'd be like 768 hundredths. So I can just divide 100 from 75 264. Right there, that'd be 75,264 divided by 100 equals 752 and 64 hundredths. Right, so I'm doing the same thing that I've been doing today. I've been pulling off decimals and then changing them back, or vice versa, right? We can move decimals around sometimes, as long as we know when to move it back. So if I divide it by 100 at the beginning, I need to times it by 100 at the end. And if I times it by 100, I need to divide it by the end. That's how we move it backwards. So let's go ahead and look at B. I'm going to let you try to do B and C by yourself. And I'm going to have you pause the video, and I'll have the answers pop up in 3, 2, 1. So our answers look like this: 1,140 and 99 hundredths, 5,699 and 4 tenths. Make sure that you notice right here that there is only one decimal place value. I'll highlight it real quick. Between these, right over here, the decimal only moved one spot, so we're not most of what we've done so far is dividing and multiplying by 100. But if it only moves one time, then we're going to divide by 10, not 100, right? So make sure that you are mentioning that you're using 10. If you got these right, go ahead and kiss your brain. So right here, where's my pointer? Jenny buys 22 pens that cost $1.15 each and 15 markers that cost $2.05 each. How much did Jenny spend? So remember, when you get started, what we talked about in class, just when you set these up, multiplication, just let that decimal fall straight down. That's the only clue I'm going to give. You just set it up like standard algorithm, but let the decimal fall straight down. I'm going to have you pause this video and do this by yourself, and I'll have the answers pop up in 3, 2, 1. So you should have gotten the answer along the lines of Jenny will spend $56.05. Right, so make sure you're, if you didn't get that, go back and check. Make sure that you got your partial products correct. And then if you got your partial products correct, see if you added those up right. And then if you added those up right, make sure you added these up right. Right? If you got the answer, kiss your brain, and let's move on to the next one. I'm going to read this real quick. A living room measures 24 feet by 15 feet. An adjacent square dining room measures 13 feet on each side. If carpet costs $6.98 per square foot, what is the total cost of putting carpet in both rooms? So this is another multi-operational, multi-step problem. Let's go ahead. I'll set up a diagram for you real quick. So we've got a living room that's 24 feet by 15 feet, which means 24, 15. And if it's a rectangle, that means this side is the same and this side is the same, right? But we don't really need to know those to find area. That would be perimeter. But I'm just for drawing. So this number times this number. And then an adjacent square dining room measures 13 feet on each side, which means that it's 13. And if it's a square, it's 13 on every side. So I'm going to do 13 times 13. This will give me my square footage for this. This will give me my square footage for that. Square foot being the key word right there. That's all I'm going to help you with. go ahead and pause the video and solve this by yourself. And I'll have the answers up in 3, 2, 1. So the answer should be something like this. It will cost $3,692.42 to carpet both rooms. So right here, we got our 360 feet, 169 feet. So that's this square feet, and that's this square feet. But we need carpet for both of them, so we need to add those together. So that gives us, right there, that gives us the 529 square feet altogether. And so the 529 square feet times, up there, 698 per square foot. And that's going to give us the final answer down here, 3,692.42. If you got it right, kiss your brain. And if you're not sure what was wrong, go ahead and pause the video and talk to Mr. Cooper. Other than that, you can go ahead and get started on your exit ticket.